Hello, good afternoon, everyone. Welcome to another episode of Rstudio tutorial. My name is Brandon, and this is Liquid Brain. Today, I'm going to talk through the package on what we call a ggplot2. So it's a very commonly used visualization tool for big data in R. So I'm going to talk basically 6 different points today. The first one will be some basic structure and syntax on ggplot2. You know, how to start off when you have the data set that you want to draw. So what is the first thing that you do? So once you got that, then we have to go look into what is your data structure, what is the aim goal that you want to draw. So how to figure out the difference between continuous data and discrete data, and how to plot things with the correct graphics. And then we go into what is the aesthetic definition of the data itself, as well as there's aesthetic for individual different type of graph as well. Of course, then we go into the actual plotting process. The first one will be primitive plots, will be just a horizontal line in the plot canvas and a vertical line in the canvas, as well as, let's say, a slope in the canvas. How do you do that? Which is actually not from the data itself. Then we, of course, go a little bit more advanced into a single variable plot. In that case, there will be something like a distribution data, which is a histogram. You can do a geom bar and so on. You'll see some example later. So once we're done with a single variable, we're trying to do two variables. So that's x and y. So you can do a geom text, geom point, geom jitter, box plot, and so on. So those are based on two different parameters and can be continuous and discrete. So there are 4 different combinations that we're going to go through. So lastly, we're going to actually draw the data based on the COVID-19 actual world case data that I downloaded from CDC. So the first thing that you need to do, of course, is to install ggplot2. So that's fairly straightforward. Go to package, click install, and just click ggplot2. So just install find the ggplot2 package, press install. That will walk you through the process of installation, and usually you will just install just fine. ggplot2 is a relatively straightforward packages without too many kind of prerequisites. So usually a straight clean install, you work fine. Okay, so once we've done that, let's just run our first command, which is library ggplot2. So this would tell the RStudio to load ggplot2 into the current environment, so you are able to use the command directly later. So today we're gonna use public data called empty cars, and I'm gonna declare into object what we call a data. So this is not a common thing, but it helps people to easily visualize that this is the data set they're working with, because it will actually appear on the top right corner over here. So this is actually data from 1989 where they try to build multiple regression models. So you can actually have a look on the source material over here. So the first thing is always to look at the dimension of data, how many columns and rows are there. So there's 2 ways. The first one is through a command, which is dimension data dim, open close bracket, and put your object inside. So that will tell you that's 3211. So the first one is always referring to the observation, while the second is always referred to as the variable. So if you click in over here, you can see that there's 32 rows of data and 11 columns. So in R, observation is also the rows, while variable is always the column. So that's how they differentiate between different. It's just a different naming scheme for the different system. So just to have a quick look at our data over here, where we have MPG, we have cylinder, we have the horsepower, we have their, I have no idea what is this. Let's go back to the previous one, we can have a look. Okay, so to actually understand different data, you can actually use a command called structure, str, and open close bracket, and put your object in the middle. That will give you the basic idea and information on the data frame itself. So as you can see from the output itself, this object is a data frame. There's 32 observation and 11 variable, and this is the one that you want to look at. So in this case, all 11 variable are numerics, so they're numbers basically. And the individual definition of the short form over here, I actually have summarized. I've not summarized. Actually, I have pulled down the information straight from the website. so that you know the mpg is a miles per gallon, which is their fuel consumption on individual cars. Qsec is actually the quarter mile drag race time, which is how fast they are in accelerations. AM is the transmission, where 0 refers to automatic, 1 equals to manual, and so on. So you also have number of gears and number of carburetors and so on. So these are the different type of data they work with. So in this case, all 11 of them are numeric, which means that all of them are actually continuous data. There's no discrete data over here. We'll go to discrete data when we reach there. So the first thing in trying to understand is that when you look at the data like this, what kind of graph do you want to draw? So in this case, let's think about what we just want to visualize. There's two different parameters, gears and mpg. We want to know if the more gears a car have, does it have a better miles per gallon relationship. So try to think about all this thing in your mind before you even start to plot the data. So once we have that thought out, so let's see how we can put the syntax to works for ggplot. So the first thing, of course, is to do a function called ggplot. Put your data in front, so that will be the first parameter that you feed into ggplot, and then you define a static, what is x and what is y. In this case, you don't always have to declare both of them. If you only have a single parameter, you can just put x equals to something. So that would work as well. So they are very specific to the plot that you want to do later. So this is what we call defining the data and a static for ggplot itself. So ggplot is a kind of layering structure where you have the basic data and the static defined, and then you add layers to it to add different elements to your graph. So once we run the first command, it will actually generate an object called A. So you click into A, you realize that what are the data, what are different layers. Currently there's no layers yet. What are the scaling, what are the mapping coordinates and labels and so on. So these are the different objects that mix up to your graph later on. So let's now add the first layer. So the first layer is actually adding a blank canvas, which is what we call a GEOM blank. So you can ignore the GEOM here. It's just telling people that this is a ggplot object that you want to add on. Every single graph will be preceded, I would say, preceded by GEOM underscore something. So GEOM blank means it's empty. So if you run the first command over here, you will actually add the layers into the object just now. So let's go into object just now. You realize that we have more layers over here because we have added the blank canvas. So how do you print out the graph? It's just type A and press run. So that would actually give us the object. So once we've done the blank, which is blank canvas, let's look at the second and third data point. So y limit is actually the limit of the axis. So you can see the y axis over here. We are plotting it from 0 to 35, while x we are running from 0 to 5. So that will actually give you a blank canvas with a very specific x-axis and y-axis. So once we're done that, we want to add a horizontal line. So in this case, H line means it's a horizontal line at 25. So it will actually intersect at 25 over here and draw a horizontal line. So let's just run it and check it by exporting it by pressing A and run. So in this case, you can see we have done a horizontal line at the 25 mark, and now let us add in a vertical line. So a vertical line will be V line, which is vertical line, x-intercept equals to 4, and just press A again and run it. So we have added another vertical line into the plot again. So now we're done. Let's go to the third one, which is AB line. So AB line actually is a straight line, but it's not horizontal or vertical only. So this is basically a slope, if you really want to understand it that way. So if you want to add in the slope, we just say A plus the geom AB line, intercept equals to 10, slope equals to 5. So in this case, the intercept equals, let's just actually run it. It's easiest to demonstrate directly. So you can see it actually intercept y at x0 over here, because the plot actually gives us a little bit of leeway in front of 0. It doesn't show 10 here, but I can assure you that when x is equal to 0, y is equals to 10. Okay, so the slope equals to 5 means that the y equals mx plus c, intercept is c, and then slope is equals to 5. So c is equals to 5, while no, c is equals to the intercept, well, m is equals to the slope. Yeah, you know, standard quadratic equation for you to draw a slot line. So the final A over here will be able to print out the data. So usually if you want to just draw the graph without, you know, checking individual step, you can highlight the whole thing and then run it as a whole. So that will generate the graph directly. So you can also go back to the object and realize that the layers have a lot more object because we're adding more and more and more things into this object, so that if you export A, it should actually just give you the graph itself. So you store whole graph into an object. Okay, so that would actually conclude our a very primitive and very basic plot, as well as a little bit of data structure. So now let's go into a little bit more practice by going into a single variable plotting. Okay, so now this way we're gonna try to change a little bit of our variable so that it has a little bit more different type of data that we can use and look at. So the next variable is actually an object, a publicly available data set called MPG. So you can actually go to the website to see the sources and where they come from and so on. So first thing first, always check the dimension of the data. So it's 234 rows, which is 234 observation, 11 variables. So it's a lot bigger, and you can see there's a lot more things over here. There's words that we don't have just now. Just now, everything are just number. Here, things are a little bit more dynamic, so you have a lot more things to look at. Okay, so let's go to, again, check the structure of the data set. Whoa, we don't want the narrator. Thank you very much. Goodbye.
Narrator.
Interesting. So the next one is, of course, check the structure of the data set itself. So you can see the table. So table is actually a table, or you can actually understand it as a data frame. They are very similar in this context. They are not very similar. They're not similar in many other ways. But in this case, it doesn't really make any difference. Okay, so you can see the first one is a manufacturer, which is a character. There's a model number of the car, there's displacement of the car, there's the year of the car, cylinder, transmission, and so on. So if you don't know, CTY is city miles consumption value, which is their fuel consumption value in a city and their fuel consumption value in a highway, and so on. So of course there are different FL and there are different classes. So these are all different type of properties of a car. Okay, so now let's just start with the first discrete parameters. So the main difference between discrete and continuous is that discrete are usually factors, so they can be classified into individual blocks itself. Like gender will be male, female, and everything in the middle, so there are others. And let's say you have a number of cylinders, so you have 4, 5, 7, 8, 9. So they're just discrete group. There's no such thing as 2.5 cylinders in a car. There's no such thing as a year, which is 2008.2, 2008.3. When we define a year of a car, it's always just 2008, 2009, 1990, and so on. There's no crossover in the middle. So everything is very distinct in class, and that's it. So like manufacturer model, obviously it is Audi, BMW, Ford, and so on. There's no half Audi and half BMW. So that's the main difference between continuous. But for a data such as the displacement, which is a number, there's 1.8, 1.8, there might be 1.81, there might be 1.85, there might be 1.81535. So there's always things you can cut in the middle for continuous data, which is the word means continuous, while discrete data is only in different buckets. Okay, so in this case, we're gonna go for one discrete parameter first. So we're gonna plot something called FL, which I have no understanding. They're just different type of class of the car as part of the properties of a car. So in this case, we're gonna use the same thing, ggplot, and then we put the data in. So the data here is just called MPG, and the aesthetic here is the FL. So there's CDEPR. So you can understand a little bit more on the data set itself. So this is just an example of how we can draw a bar chart based on a single one. So what the aesthetic here is actually using the count, not the aesthetic, the aggregation function is actually the count. So you can see there's a lot of R, less P, E a little bit, and C is the least amount of them. Okay, so you can see the structure is very similar of how we draw the primitive graph above, which is first thing with a ggplot function, define the data set itself and the main parameters that you want to plot, and then you add on the layers for the actual plotting that you want to do. In this case, a geom bar, so a bar chart. Okay, so for instead of plotting discrete, what if we want to plot continuous? So in this case, we want to use a histogram and actually automatically bucket them. So histogram and bar chart are very similar to each other, except bar chart are usually used for discrete, while histogram is used for continuous, because histogram has a automatic bucket function, and you can define the bucket into whatever size you want. So in this case, first thing, again, use ggplot to define data set, add on a histogram and print it out over here. So in this case, the bin are using 30, so pick a better value with bandwidth. So we'll go through that when we reach that. Every single plotting function and layers over here has individual parameters you can actually tweak. So you can see over here for the count, there's a lot of cars with 4-cylinder, there's a lot of cars with 6-cylinder, and there's a lot of cars with 8-cylinder. And there's a few cars with 5-cylinder, which is really weird. And there's no car with 7 cylinders. Makes sense. Cylinder are usually even numbers, so they can cancel each other out. 5-cylinder usually comes in a circling engine where there's a way of cancelling each other out without having problems or imbalance. That's why we can also have 3-cylinder car with a 120-degree offset and so on. But this is how we can easily visualize the data. So I feel like this is not a very good example of a histogram, because the cylinder is not a very good continuous data over here. So we'll try another one with displacement. So displacement is basically how big is the engine. So it's a 1.8 cc, 1.8 liter engine, a 2.4 liter engine, and so on. So you can see using the default bin over here, we can actually kind of see the distribution of displacement for the sample size over here. So 2.4, 2.3, 2.5 over here is the most common one, and there's a very little cars with like more than 6-liter engine, because obviously those are supercar territory. So this is how you can bin them, and of course you can change the bucket so that you only show between 2 to 2.5, 2.5 to 3, and so on. So you can customize the width of the bar over here using a histogram. So you can also change it. Let's say I want to do CTY. So there's a CT MPG, the fuel consumption in the city. So again, you can see something similar where most of it is between 10 and 20, and everything above 20 is a lot less, which is most likely correlated with, bigger engine, less efficient, and so on. But if you have variant parameters, that's usually very straightforward. Figure out whether it's a distinct one or continuous one, and choose the function that is suitable for a process. So in the meantime, I actually want to promote a little bit on the Rstudio cheat sheet. You can download it from the website. So in this case, you can actually see for one parameter continuous, there's the area, density, dot plot, frequency, polygon, histogram, and QQ that you can choose from. Depends on the situation that you're in and what kind of graph that you want to visualize, basically you want to plot. So of course for discrete, relatively straightforward. Is only for geom bar would be the most straightforward and easy to represent one that you have to. So let's just go into 2 variables over here. So we'll come back to this. Let's go back to our example here. So for 2 variables, of course you have 4 different scenarios. So you have continuous and you have discrete, and you have 2 scenarios. So 2 to the power of 2 is actually 4. So there's 4 different scenarios. Let's go to the first one, which is continuous X and continuous Y. So if you are familiar with plotting, the horizontal line is always referred to as x-axis, while a vertical line here always referred to the y-axis. So let's try to plot our first one. So same thing, use ggplot to define the data, and then use AES to define the 2 main structure that you want to plot. So you can either directly put it in without actually telling them which one is which, where they will automatically assume which one is the X and which one is the Y. And we'll see what happens later overall, isn't it? So if you did define, we will just port it into object called E. So you can see here, I'll just put E plus geom point. There's no arrow over here. So what this means is that I directly want the output to be displayed rather than port it to another object. So you can do it if you just want to visualize the plot without actually saving it to an object. So if I run this, you can see directly I have a plot. So if you don't define it, the first one, CTY over here, it will be defined as the x-axis, while the second one will be defined as the y-axis. So this is the geom point, which is straightforward enough. It's just a scatter plot. However, the problem is that you actually have more than one data point at one single location. So ggplot also provided something called jitter, which try to add a random noise to each of the points so that they're separate out, so you can visualize the number of dots better in a certain location. So that's just one of the functions that I put it in. Okay, of course, we don't just have to do that. We can also do something called geom label. We actually label down the thing directly on the plot. So instead of the dot, you can actually put in numbers of one of the axis. In this case, you can see 29 over here corresponds to the x-axis value. So of course, you can also change it to HWY, which is the y-axis value, where the plot will correspond to the y-axis value. Okay, so of course, you can also use a tag so that that would not constrain that to a label. It would be a point, what is that called? A data point directly as the text. So a text data point replaced with a text basically. So this is especially useful for, let's say you have not just numbers, you have like name of the country, names of the test object, human names, and so on, and to visualize directly where they are on the plot. Okay, so once we're done with continuous x and y, which is usually the easiest one, let's go to discrete x and continuous y. In this case, we'll be looking at the class of the vehicle versus their highway fuel consumption. So class actually have like compact, we have like SUVs and so on. So it depends on the type of the car and class of the car. So same thing for object F, we're gonna just declare the basic variable and declare the basic structure of ggplot, and then we add it with a box plot. So you can see there are different class of car. There are two-seater, there are mid-size, there are minivans, pickup, sub, compact, and SUV, and so on. So a box plot is very good to visualize the mean of a class as well as the spread of the class. So you can see that subcompact car over here as a relatively average and mean, but the spread is huge, means that within the subcompact category itself, the fuel consumption can vary wildly. While something like a two-seater, it's almost always the same fuel consumption. So same happens. So yeah, same you can observe with SUV, where the mean are relatively low, but the spread are relatively high compared to a pickup truck, which is always gonna consume more fuel on the highway because they are just bigger. So this you can easily tell the relationship between the two variables using a box plot over here. So beside a box plot, we can also use what we call a violin plot, which is basically same as a box plot, but instead of using box to represent the spread and the 50%, 75%, and 25% percentile, so violin will give you the size of the sample within a certain range, so we can actually visualize it directly by looking at the violin plot. So once we're done with one discrete and one continuous, let's go to discrete x and discrete y. So this basically means that both sides are discrete. So in this case, we are using a class, which is the same thing that we use over here, and drivetrain, which is front wheel drive, back wheel drive, or four wheel drive. Okay, so same thing, run this and run this. So this will actually give us, in rear wheel drive, we have SUV, subcompact, and two-seater. So relatively small number in our data set. But you can see there's a lot of SUV with four-wheel drive and a little bit with rear wheel drive. We have a lot more mid-sized car with front wheel drive and so on. So this is easier to visualize a distribution between the two discrete variables using a geom count basically. So of course you can color them, you can try to do shading, transparency with them afterwards. So we'll go down to the other one. So you realize that I missed something out. What if we have a discrete y and a continuous, so discrete y and a continuous x? You can just flip the axis and they will do exactly the same as the middle. So you can just flip it so that the bar, instead of horizontal box plot, it become a horizontal box. Yeah, you can actually switch between X and Y axis if you need to. So it's usually a better way to display a discrete X and continuous Y, where it's just more familiar to the most of the user. Okay, so instead of just doing the two-dimensional, you can actually plot things on more dimension. We're gonna go through that next time. But for now, let's just try to see how we can make our two-dimensional plot more interesting by adding, let's say, the color, the size, and so on. So we are adding more than two-dimensional on a two-dimensional plot. Okay, so same thing with this. We're just using MPG with city and highway, so that's two continuous variable. But in this case, we have done this already. So we have done the labeling, but now we want to add color. So in this case, we are coloring the different numbers and different plot with their manufacturer. So you can see that over here, you have the purple color, which I believe is Subaru. And we have here the green color, which I believe is a Hyundai or Jeep. So it's not very clear because there's a lot of different manufacturer, and the way of me looking at color isn't very good. But you can see there's a purple cluster in the middle, there's a green cluster over there, there's another type of green cluster over here. And if you have better eye, you should be able to tell this brand directly has dominated a certain niche in the market based on their fuel consumption. Okay, so besides just the color, we can also do, let's say, we want to see their we can also color based on the cylinder size, which is much easier to see. You can see that all the cars with a better fuel consumption are all the way up, and all the car with a lesser cylinder are better in terms of fuel consumption, where car with more cylinder consume more fuel, which makes sense. Bigger car with bigger engine consume more fuel. Okay, so we can also again color it based on the manufacturer like they just now. And now instead of just using a color, we can also change the shape of the plot. So this will give you a further dimension of visualizing directly with their manufacturer, the number of cylinders, the highway and city fuel consumption all in one. So that's 4-dimensional in a single plot. So of course, again, you can still add another dimension with the size of the plot with the displacement. So you can actually see a lot more things in the plot. But here is a bit of overplotting. It's really hard to see, and usually we don't put too much data in one plot because it just becomes really difficult to differentiate which is what and where is where. So we try to focus on what kind of thing do you want to tell, and just plot the simple, straightforward story, a plot that can actually tell your story or your hypothesis. Do not try to squeeze everything in one. Okay, so let's go a little bit on the practical data. So we have talked through all the single variable plotting, dual variable plotting, continuous data, discrete data, how to add color, shape, size, and so on. So now let's go to a little bit more of a practical. How do we actually use ggplot2 in real life? So because of the recent events, I'm trying to plot the data based on COVID-19 distribution and the new cases found in different countries. So I found a data set on this ECDC Europe website where they have all the newly found cases worldwide, nicely labeled with their geographical locations and their populations and so on. So I'm going to try to read this as a could not find a function read Excel, doesn't matter. So we'll try to read this data through an inbuilt function called read Excel, which actually you can do from here, read Excel, and I'm gonna go to the place where I save my documents, and we'll just so you can actually have a look at the data to check if everything is correct, and we can import. Okay, so we have imported the data directly over here as an object called COVID-19. Okay, so first thing first, before we even start visualizing the data, think about the plot that you want to do and how you want to do it. So here I define something very straightforward, two main graphs that I want to draw. First one, I want a comparison between different countries using a line plot over time. So over time, I want to see the growth of the new cases in different countries. And for the Y, I want it in log 10 value because, the spread of this pandemic is in the log behavior. So if you plot it on a straight line, it doesn't actually show the real spread, and plot it on the log allow you to see a little bit more details into country with a lower number of cases rather than get dominated by, let's say, US and Spain and so on. So secondly, I want a total new cases. Actually, it's not just total cases, it's not a cumulative one. So a total new cases in the world in a stack column with each country represent its own color. So I want a way to visualize how many new cases are there in the world, and I should be able to see directly which country is doing worse just by the color alone. Okay, so first thing first, look at the dimension. So object COVID-19 not found. That was weird. Okay, geographical. So I forgot to delete a little bit of stuff just now. So let's just do another redact cell again, and we need to delete this. Okay, so this will rename the object as COVID-19, and I don't know why COVID-19 here works, it doesn't work just now. So let's just import, and now we will have the object called COVID-19 over here. Okay, so let's see the dimension of the object. So we have 11,000 line and 10 different columns. So of course you can open up the object and have a look on the structure itself. So we have the date of the reported, we have the day, month, year, not very useful for us, and also we have the cases, which is the new cases found that day, what's the new death, the country code, and the population, and so on. So in this case, we only want to use the date reported as well as the number of cases on the country. Okay, so we mainly focus on this three. Okay, so same thing, just run, make sure that which data that you're looking at are discrete, and which variable you look at are actually continuous as well as the discrete one. So you can see for the first one, date reported is a POSIXCT. I don't know how people pronounce that, but basically a date format. So when you see a POSIXCT is actually the unique, not Unicode. Like everyone would know that this is the date format, and we will be able to sort by the date very easily to know that this is a time series data. Okay, so day is a number, month is a number, year is a number, and case is a number. So these are all continuous data. And death, yeah, because technically year is kind of a discrete, so that's kind of a blur line in between those. Number of death, of course, is technically also a number, and yeah, it's a fine line between like numeric value, whether it's a discrete or a continuous. Still depends on the context that you're trying to measure them with. But if you see things like a character, you definitely know that discrete, and if you know that GeoID, that's definitely discrete, and so on. Okay, so we're gonna use a little bit of external library here called dplyr. So this is a very commonly used library for data manipulations and summarizing. So what I do is that I put the object and I try to group by the countries and try to summarize the number of cases of the country, so we can focus on just want to focus on country with biggest cases, or do we want to focus on country with smallest cases? So this gives us an overview of all the country and the number of total cases they have right now. Okay, so you can see that Australia has about 6,005, Bosnia has about 1,002, and Brazil has about 36,000, which is pretty bad. So this gives us a total number of cases reported in the country. So this doesn't consider people that have been removed, which is they are either recovered or cured. So these are just pure infection numbers. Just keep that in mind when you're doing the rest. Okay, so now let's go to the actual plotting. And because I am actually not able to open my fan because it will affect the microphone, it's actually very hot in here. Okay, so let's get back. So the first one, we try to do a comparison between different countries using a line plot. So a line plot usually have x-axis as the time, y-axis as the number of cases in log 10 in this case. Okay, so first thing, same thing, just ggplot, define this is the object, the data frame that we're going to plot. We want to slot in, x is the date reported, obviously, and y is the number of cases. So we don't do the scaling yet, we'll do the scaling later. So the plotting is fairly straightforward, CV plus geom_line, so that will plot a line plot. And if you want to scale the output, you can just put this, and that will actually give us a nicely scaled data of the total new cases over time. Okay, so this is give an idea that in February we have kind of a big mountain over here, this is because of the outbreak in China, and they slowly recovered before it was discovered in the rest of the world, and the number has been growing ever since the end of February over here, and number have been growing, and it's stabilizing a little bit over here, but beware that this is log curve. So if we look at absolute value, it's still massively increasing in a lot of country. So now basically we've done the first chart. That was very fast. Okay, so the second, let's go to, we want a total case in a world in a stacked column plot with each country is its own color. So since I believe everyone's already quite advanced, we are 35 minutes into the video right now. So CV is, we can reuse this because we are using the same data, we're using the same aesthetic over here. So what we do is that we are plotting a column chart, which is what we have talk about before this. So column chart, if you actually look at the cheat sheet here, it's actually for discrete X and continuous Y, but you know, it can be used in this situation as well. So actually I need to explain a little bit for geom line before we go forward. You realize that geom line, if you look at here, they're actually a smooth line with nothing below over here. But the problem is that when we report the data, they will actually have things like weekends, and they'll have missing data point. So what happened to this line is that it's just going up and down, up and down, up and down, up and down, because certain dates itself doesn't have any data point. So maybe we can try to remove that, but I think for the visualization purposes and to understand data itself, I don't think it's necessary over here. If you do want, just run a filter based on a certain cutoff and you should be fine. Okay, so let's go back to our second one. So we want a column chart. So we are trying to color a column chart based on the country that we have. So it would appear as a different country, and maybe just try that first before. Let's just try it one by one. Let's try out the actual process of building it on. Okay, so in first one, we just want to build the chart with a column with the color as a different country code, and we'll see what happens. And because it's quite a big data and there's a lot of countries, it would actually take some time to generate, and they wouldn't really understand how it should do. So yep, the problem here is that what you see over here are just the legend. There's nothing else, because the plot dimension, the size of the plot is so small, it gets dominated by the legend. So you can resize a little bit, it should reload or it should not. I mean, because it's a big plot, they need some time to figure it out. So you can see there's a plot, but this is just too big and I don't care. So I need to get rid of them. So let's just try to get rid of them. Okay, so let's get rid of them in the second one before we go scaling, shall we? So to get rid of them, we actually run something called theme. Theme is actually the theme of the plot itself, and we say legend position none. So this should get rid of the legend for us. Same thing apply, because it's a big data set. We are unable to, and then it will run. So of course, without plotting out the legend, it's a lot faster. We can see kind of the same trend that we've seen in the line plot just now. However, now you can actually see the colors that belongs to different country. I believe that this is obviously China over here in February, and one of the biggest color over here is either US or Spain. Okay, so let's just run the last one. No, actually not the last one. There's a few more. Okay, so this will actually scale the number in log 10, and this should give us a little bit more of a linear growth rather than an exponential growth like what we did earlier. Okay, so there are one row that's missing there's a little bit of problem. So doesn't matter, don't care. It should appear later on. Yep. I forgot to put this in. Okay, so let's just do this properly before we go to the next step. And the problem is that because there's so much country, it's very hard to visualize, and there's a lot of country with very little cases that it doesn't really affect our results. So we do not want to see them. So what we do in data science and data visualization usually is remove those country that doesn't really have enough thing for us to worry about. So when we want to look at this graph, I just want to look at the country with a very, very high infection rate. So in this case, you can just click here, sort by cases. Of course, this is small data, you can do that. A big data, you can't really do. So let's say we just want to select a top maybe 10 or 20 of them. Let's set a cutoff point. So the cutoff point I set up previously is 30,000. So we are just gonna go for all these country and plot them on the same plot over here. And we should be able to put a legend beside it, and still see everything clearly. So let's try that. So of course, we are again trying to use DPYLR way of filtering the data, which is we have the object and we group by the country first, and then we run a filter where the total number of cases will only be included if they are larger than 30,000. Okay, and we send that whole filter object into a new object called COVID-19s. So it's a string down version of the whole thing. So, and we run the same thing. We include another object called CV2 so that we don't confuse the previous object with the object now. And we run the object called CV2, and then we run another one called the same column. But now you can obviously see, just now we can't even tell which color belongs to which country. Now we can tell that this belongs to China, CHN, and the biggest chunk here actually belongs to USA, and a little bit on the green color here maybe is ESP, which is actually Spain over here. So that's basically done. Let's just run our last one before we close the thing. So we can actually see with a log curve, it's much easier to see country with a smaller number rather than it getting dominated by just US and Spain alone. Now we can see that Brazil's here, Spain is here, France is here, Great Britain is here, Iran is here, Italy is here, Netherlands is here, and USA is here, Turkey is over here. So very easily we can see the spread and the growth between each country and so on. So let's just go for a recap. So today we're talking about ggplot2. So we start from beginning where we explain the basic structure of, let's say, how to install ggplot2 in your R environment, how to include it in your environment, and how do you start with it. So of course, the first thing that you do in ggplot is to run the functions like this, where you try to tell ggplot what are the data you want to include and what are the basic aesthetic. So it could be the x-axis and y-axis, maybe other axis if you want to include. And how do you explore a data structure? That will be usually, there's many ways to do it. For myself, I would just look at the dimensional data, which is how many columns and how many rows they are, and do you need to run any filtering on it. And of course, as well as the structure of the data, so we can see which one is continuous, which one is numeric, and what are the things that we might need to convert to factors and so on, so that it's easier for downstream operations. So aesthetic definition here refers only to the x and y axis, and how do you tell the ggplot that which variable belongs to which axis. So that is the aesthetic of the plot itself. And there are of course different aesthetic when you go into different commands. Like I think here we have one. You can see the aesthetic of the label. So aesthetic of the label will be a different thing compared to the overall thing that you just now. And you can put different variable in the aesthetic of text if you have not included in the original ggplot decoration above. So you can always try a different thing and see if it works. And then we go into the plotting, which we try the primitive, which is the horizontal line and vertical line. We try a single variable, which is the histogram, the bar chart, and so on. We also try a two variable plot, which is a text, point, jitter, box, and various other, and geom count, and so on. So lastly, we actually use the knowledge that we just got and try to plot the data on the recent COVID-19 data it's downloaded from CDC. So I think that's conclude our data for ggplot2. For further information, there are actually something called ggAnimate, which is actually taking ggplot to the next level by stacking them and create an animation. So that will be the part 2 of this tutorial. For now, I hope you enjoy the ggplot2 over here. We will see you in the next video. Bye.